Alright folks, welcome back. And we're going to do a little bit of review right now. We just finished up learning how to name and write formulas for acids. Before that we did covalent compounds, and before that we did ionic compounds. So we have all of this stuff going through in our example 30 here, kiddos. Let's name the following. And of course we'll assume each one's dissolved in water. Okay, so we're going to assume that they're all AQ, kiddos. So why don't you try these 5, pause the video, and then come back and see. Really, take the time to try this on your own. If you make a mistake, it's no big deal. No one's going to know, unless your mom's looking over your shoulder. But no one else will know. And then come back to the video and see how you did. See if you're getting these or not. Okay? See you in a second. Okay, welcome back. So letter A, HI. Remember we said to assume that these are all dissolved in water. So do you recognize that as binary? Only 2 elements, right? So what prefix do binary acids begin with? That's right. Hopefully you started with hydro, right? Now, the nonmetal is I, and so we end that with IC or ic. So we call it hydroiodic acid. Is that what you got for letter A? If you did, good job. All right. How about letter B? Did you recognize that as ternary or an oxide elements? So for this one, folks, we have to look at the polyatomic ion that it's stuck to. And so let's look up ClO4. So ClO4 is down here. It's -1, and we call it perchlorate. Did you remember what 8 polyatomics turned into when they were being named as acids? That's right, 8's become X. So instead of saying perchlorate acid, we would say perchloric acid. Once again, we don't start ternary acids with hydro. All right, how about ClO2? All right, it's ClO2 is the polyatomic. Let's look that up. ClO2, here's ClO, ClO2 right here. Now that's called chlorite. What do ites become? That's right, they become OUS acids. So this becomes chlorous acid. No hydro again because it's not binary. Okay, how about H2SO4? What is SO4 called? Well, that's pretty common. You might know that without me looking it up for you. Here's SO4. It's called sulfate. So H become X. So we call this not sulfic, but sulfuric acid. Okay? And then H2S. That's binary, isn't it? We assumed all of these were dissolved in water. If it's binary, you know we're going to start with hydro, right? Then we change the ending of the nonmetal to ic. So we'd call that hydrosulfuric acid. How did you do on those 5? Good. All right, let me try a couple more before we do example number 31 for you. Let's go the other way. Let me give you the name and see if you can come up with the formula for the acid. So what if I gave you H3PO3? Okay, try that one. And what if I gave you, let's try this one, ClO3. Oh, you know what? I want to give you the name, don't I? Not the formula. So let me go back. Sorry, my bad. So let's try this, okay? Sorry. Let's try Phosphorus acid. Okay, try that one. And then try, let me think of a good polyatomic ion that maybe we haven't used in a while. Let's try, there we go, Hypochlorous acid. Try that one. Try writing the formula for that one. And then finally, let's try a binary acid that we maybe haven't done in a while, so let me take a look at the periodic table and see if I can come up with a good one for us. I don't think we've done this one. Hydrofluoric acid. Okay, so take a minute and try writing the formula for those three. Then come back to me. All right, welcome back. So, phosphorus ends with OUS, so phosphorus comes from phosphite. So let's see if we can find phosphite. Here's phosphite, and it's PO3, 3 negative. So PO3, 3 negative, and it's stuck to hydrogen. That's acting like a metal with a 1 plus charge. So it would be H3PO3. We need 3 positives to balance out that 3 negative. Okay? All right, hypochlorous. So hypochlorous, once again, that one ends with OUS. So let's see, that comes from hypochlorite. So let's see if we can find, oh, here's hypochlorite right there. It's ClO1 negative. So ClO1 negative, and it will be stuck to a hydrogen acting like a metal with the 1 plus charge. We just need one of each of those. HClO would be the formula for hypochlorous acid. And then hydrofluoric, well, we know it's a binary acid. So we have H plus, and fluoric comes from fluorine. So fluorine's right over there. Isn't that 1 negative? And so that would be HF with an AQ after it. Alrighty, remember binary acids only exist when they're dissolved in water. So those should have an AQ written after them. Alright, now let's try a few others here. Now you're going to notice there's some covalent compounds mixed in example number 31. So be careful when you do these on your own. So take a couple of minutes, do it on your own, and then come back to the video and see how you did. Alright, welcome back. Here we are with 31A, dioxide. So let's see, that's a nonmetal to a nonmetal, nitrogen and oxygen. Dinitrogen means 2. Trioxide means 3, so N2O3. Is that what you got? Good. Nitrogen monoxide. So we have nitrogen and oxygen. There's no prefix here, so there's one of those. And mono means 1, so just one of each. So NO would be the formula for nitrogen monoxide. Okay, how about hydrochloric acid? Well, we know it's binary, so we only have 2 elements. Hydrogen acts like a metal with a 1 charge, with a positive 1 charge. Chlorate comes from chlorine, which is negative 1. So the formula would be HCl AQ. Okay, chloric acid. Okay, now that's not binary because it does not start with hydro. So chloric must come from chlorate. So let's find chlorate over here. So we're looking for chlorate. There's chlorate. It's ClO3 negative 1. So ClO3 negative 1, and hydrogen acts like a metal with a 1 plus charge, so that would be HClO3. Sulfuric acid. Sulfuric comes from sulfate. We just used sulfate not too long ago. Here it is. Here's sulfate, SO4 2 negative. So SO4 2 negative, so the acid would be H2SO4. And then finally, sulfurous acid comes from sulfite. So sulfite is right over here, SO3 2 negative. So the acid would be H2SO3. Okay, hopefully we've beaten that up pretty well for you so you guys can do those on your next assignment. Now before we leave this little review, I want to do a few ionic compounds just to bring you back. I know it's been a few days since we've done them and you may have forgotten how to name and write formulas for ionic compounds. So let's just do a couple real quick. Al2O3, I want you to name that compound. I want you to do MnO2. In fact, let's change that. Yeah, let's leave it as MnO2. I want you to name that one. And then for the next one, I want you to write the formula. So let's go with copper, Roman numeral 2, oxide. And then let's do copper, Roman numeral 2, sulfate. Okay, so take a minute and try those 4 and then come back to me. All right, welcome back. Now, I hope you did not call this one up here dialuminum trioxide. We only use prefixes, kiddos, when it's a nonmetal to a nonmetal. Aluminum's a metal, oxygen's a nonmetal, so we have to use our ionic rules. So Al is called aluminum. Do we need Roman numerals for aluminum? Well, let's take a look. Aluminum is right here. Is that one of those we need Roman numerals for? Nope, we do not. Aluminum is always positive 3. And then O is oxygen, but remember, all binary ionic compounds end with "ide." So hopefully you just call that aluminum oxide, not dialuminum trioxide. And I hope you didn't use Roman numerals either, because aluminum is one of those we don't need Roman numerals for. All right, MnO2. Mn is called manganese. Now let's find that on the periodic table, because I think we need Roman numerals for that. So manganese is right there, kiddos. So yep, we surely do. So we have to figure out the Roman numeral that we're going to use for it. So let's leave a space for Roman numerals, and we're going to end with oxide, because all of these binary ionic compounds end with "ide." And now let's figure out what Roman numeral we put there. Do you remember how to do that? Yeah, the charge of the Mn is a mystery, but we do know the charge of O. Let's look on our periodic table. Oxygen is in group 16, and it has 6 valence. Needs to gain 2, so it's 2 negative. Now there are 2 oxides, so we have 2 of those 2 negatives. Doesn't that add up to 4 negatives? That must mean that that manganese is 4 positive. So we write that in the formula as a Roman numeral. IV is the Roman numeral 4. So that one was called manganese 4 oxide. Okay, let's try these next two. Copper 2 oxide and copper 2 sulfate. So copper, let's find it on the periodic table. Yep, it does need Roman numerals. So what's its charge? Oh, it's 2 positive. See, I told you that by using the Roman numeral 2 in the name. Oxide, we just looked up, it's O2 negative. So Cu is 2 positive, O is 2 negative. The formula would be CuO, and we're done. Hopefully you did not put a 2 in the formula because of that Roman numeral 2. The 2, remember, is the charge of the metal ion. And the last one, copper 2 sulfate. So copper is 2 plus. Sulfate is a polyatomic ion. We've used it a bunch today. There's sulfate. It's SO4, 2 negative. So copper's 2 positive, sulfate's 2 negative, just one of each. CuSO4, and we're done. Okay? All right, hopefully you liked that little bit of a review. You should now be able to name and write formulas for ionic compounds, covalent compounds, and for acids. There's a different naming system for all 3. Okay, we're going to be doing bunches of these for assignments and in class for practice, so hopefully you'll get really good at it. All right, talk to you later. Bye-bye.